Hi everyone, this is day 104, 9.6, the ratio and root test number 2. It's really more of a let's put everything kind of together, all right, and get all sorts of extra examples in, not just ratio versus root tests. So the first thing I want you to do is just kind of pause the video. Let's see if you can list the 10 series that we've done in order that we've learned them or in strategy list. Now, you can try this or you can simply just copy down what we've got, but it is going to be helpful to know them. So I'm going to zoom in on the test that we've talked about, more so in the strategy list. Okay, so where do we begin? We always begin with that nth term test, all right? Then this next group is kind of grouped together because they're kind of their own lone wolf, if you will. We have the geometric series, P series, telescoping, and then alternating series. Now remember, alternating is kind of like that end-all be-all. We don't use that test until the very last resort. Then we have ratio and root. If we have exponentials or factorials, that's where these guys come in. We've got comparison tests, direct comparison or limit comparison. And then last is that integral, all right? That integral test, that's kind of most involved, and we probably don't use that very often, okay? The other thing that we've already talked about is this roadmap, okay? So again, just another place to have this roadmap listed. Remember, we say nth term test first. If it doesn't equal 0, we diverge, we're done. If it equals 0, then we're inconclusive and we have to go to all the other tests that are available. So that's 2 through 5 here. We're really just focusing on the positive series at this point. If that converges, then it's absolute convergence and we don't have to worry about the alternating series test. If it diverges and it is an alternating series, then we have to go through the alternating series test to determine if it's conditional convergence or if it diverges. If it's not an alternating series, then we're done if it diverges, okay? So these next few then are just some extra examples. I actually want you to try this example 2 on your own. All right, so I'm going to pause the video and kind of get started with it, zoom in, and then I want you to finish it on your own and see how you did. Okay, so for this first example, you would try the nth term test, but it's inconclusive, so what do you do next? I noticed it's not an alternating series, so you just have to pick the best test to use, and whether that converges or diverges, then you're done. So go ahead and finish this one up. Give it a little bit of time, come back and check how you did. You might have used a different test than I did, and that's totally okay. All right, so give it a try. I actually used the limit comparison test. I compared it to the series of 1 over n cubed, which is a converging P series. So you need to make sure you do state this when you're comparing. So that limit comparison test, now we're taking the limit as n approaches infinity of that an divided by bn, or times the reciprocal of bn, which cleans up nicely, all right? When you do L'Hopital a few times, you're going to end up with that limit equaling 2/5. Remember, the criteria for limit comparison test is the limit has to be greater than 0. And since this one is, and we are comparing it to a converging P series, this series converges by the limit comparison test. Okay? All right, next I want you to try this next example on your own. Again, if we look at it, the nth term test fails. It's inconclusive. The limit equals 0, so we can't conclude anything. So I'm going to tell you I used a comparison test. All right, now typically when I have some other things going on in our numerator, I tend to use the limit comparison test. That doesn't necessarily mean that's the right versus wrong way, but that might give you a hint. So go ahead, pause the video, give this guy a try, and then we'll compare. As mentioned, I used the limit comparison test. I compared it to a diverging P series of 1 over n to the 1/2. Now I chose that because remember, as we're trying to figure out what to compare to, I noticed that the leading term is n to the 3/2. So I need to figure out, well, what do I need to multiply n by so that I get it to be n to the 3/2. So I'm going to multiply that by n to the 1/2, and that's where I get n to the 3/2 from. Okay, so as we set up our limit comparison test, our original times the reciprocal of bn, okay, and now since everything, or I'm going to rewrite everything so that it can be raised to the 1/2 power or rewritten underneath the square root. Now, if I take this portion and put it underneath a square root, I just have to remember, in order to do that, to keep everything balanced, I really have to square that value. So that's where we get the square root of n, which is this portion here, times 2n plus 1 squared, which is just rewriting that portion. Since everything's being raised to the 1/2 power, we've got it all underneath the radical, and now we can simplify. Squaring this binomial and then multiplying it by n is where we get 4n cubed plus 4n squared plus n, and then the denominator stays the same. Okay, if we kind of go through, we should recognize when we're taking the limit, everything will cancel except for the leading coefficients. So we really have the square root of 4/1, which is just 2. Again, since that's greater than 0, we can apply the limit comparison test. Since we're comparing it to a diverging p-series, the entire thing will diverge by the limit comparison test. Let's move on to the last two examples on the back. This example was similar to a problem that we had a couple days ago in our homework, where we have the series from n equals 1 to infinity of ln of n over n. This is inconclusive by the nth term test, so I tend to go to the comparison test. All right, so if I can, I'm going to try to compare it to 1 over n, okay? Because I know 1 over n is kind of like this guy, except the numerator is different, and that is a diverging p-series or a harmonic series, so it diverges, okay? Now, I might have to change that index, right? I might have to shift over, and remember, when we shift to further terms, in the grand scheme of things, it's not going to affect the sum. So, if I do compare this ln of n over n to 1 over n, I could say that it is greater than 1 over n when n is greater than 3. So any value of n greater than 3, this holds true. So therefore, that works, okay? So that works as a comparison. Since the small, or the smaller one diverges, meaning that 1 over n, the entire thing is going to diverge by the direct comparison test. Okay, this last example, we have the series from n equals 1 to infinity of n to the n over n factorial. Now, we're thinking either the root or the ratio test, okay? Now, if we were to attempt the root test, okay, meaning taking the limit as n goes to infinity of this quantity raised to the 1 over n, well, no big deal for the numerator, but what's the nth term, or the nth root of n factorial? That isn't easily simplified. So the root test here doesn't work. So typically when we have factorials, we want to use the ratio test. So if we go to the ratio test here, I'm going to set this up initially. Okay, so we want to take the limit of, as n goes to infinity, of n plus 1 to the n plus 1 over n plus 1 factorial times, remember, the reciprocal of the original, n factorial over n to the n. I want you to see if you can take it from here, clean it up, and see what you remember from the other day of notes, and then we'll come back and compare. So give yourself a second, try it, and come back. Okay, so as we're kind of cleaning things up here, and we rewrite this as n plus 1 to the n times n plus 1 times n factorial over n plus 1 times n factorial times n to the n, we should see the n plus 1's cancel, the n factorials cancel, and we're back here. The limit as n goes to infinity of n plus 1 to the n over n to the n. Since they're both being raised to the nth power, we can rewrite that, and we can even rewrite it even further. Now, hopefully you remembered our little cheat sheet from the latest video. Hey, I have 1 over 1 plus n to the n, and I'm taking the limit of that. I know that that equals e. So we don't have to go through that setting it equal to y, taking the ln of both sides. We can simply jump to the fact that the limit of that is equal to e. E is greater than 1, so therefore we know that this diverges by the ratio test. All right, so again, this is a much easier way to go about it. All right, this is a shortcut. Use that shortcut, recognize the shortcut. All right, if you have questions, let me know.